To review, this construction consists of two distinct things. There is the exponent, which is y, and the base, which is x. X is the base, and the base is multiplied by itself however many times the exponent says. The exponent, which is y, says. Now that is a mathematical definition. It is not using real-life examples. So when I do a real-life example, 3 squared, it is 3 times 3. 3 times 3, it's multiplying by itself 2 times. It is not, and it never will be, 3 times 2. Okay? Even though every day I say, what is 3 squared? Somebody in the class always says 6. Always.
Mr. Myers?
Yes?
The exponent is S?
No, the exponent is y.
No. I'm talking about what you write in the end.
Says, you multiply the base by itself however many times as the exponent says to. So if the exponent is a 2, that's telling you to use 2 3s. If the exponent is a 7, you would use 7 3s. Okay? Mm-hmm. All right. Thank you, Omar. Now, there are in grade 9 6 exponent laws. Okay? The first exponent law is multiplication. Multiplication of powers. Okay? So, if I have 3 squared, what does that mean? 3 times 3. Agreed? Excellent. And then if I have 3 cubed, what does that mean? 3 times 3 times 3. So, if you understand both those things, what does it mean to have 3 squared times 3 cubed? 3 times 3 times 3 times 3 times 3. Do math guys like to write that out? No. So what would they write instead?
3 times.
3 to the 5. Now, what is the relationship between the 3 red boxes? They all have the same base. And
they all have the different value. They all have
2, 3, 5. You add the exponents. Now, if that happens once in math, what does it mean? It always happens. So let's put that into regular words. Multiplying powers of the same base. Please highlight same base. I'm very glad whoever said that recognized that. We add the exponents. We'll get to that. We add the exponents. Is everybody cool? Now, I'm going to write that in mathematical terms, not a specific answer. Okay? X to the a, so x with any exponent, times x, same base with any exponent, is x, same base, to the a plus b. Does everybody get it? It makes perfect sense, doesn't it? Yet, some of you will tell me this answer has to be 9 because you do 3 times 3. Even though when you think about it and write it out, you know it is not 9. It is 3 to the 5th. Is everybody cool? Great. Prove it. What is this really? 555 times 5555. How many 5s? So it's 5 to the 7th.
Okay, yeah.
What is this? Negative 6 times. So what is it really? Why did I bring the brackets all the way along?
Because it's still negative.
Because the negative is part of the base. Now look at this one. C is slightly trickier.
Because it's not the 7 times 3.
That's 7 times 7 times how many 7s? 1. Because what exponent is always there even though it's not there? 1. So that is 7 to the 3rd.
Yes.
Does everybody understand the first exponent law? Can you all explain to me why it works?
So when it times itself, it's actually just adding something.
As long as you can explain it to yourself, then I'm happy. Is that really a earphone in 2 sets of ears when I'm trying to teach after I already told you once today? I'm going to pretend like you're not ELL kids and you understand English. And I'm going to pretend that you're not deaf since I haven't had to do any sign language yet. Which means there's only one possible explanation for you to be having headphones in when I am trying to speak. That you are supremely unintelligent. And it is not that. So I am out of ideas. That would probably be a good thing to do, since apparently the temptation is too strong. Please fill this in. Go. Again, if you do not feel you need all the lines, don't fill them in. But if you don't fill in all the lines, and I give you a test, and you don't know how to do it, and I look in your notes, and I find out that you haven't been filling them in, then how much sympathy am I going to have for you? Oh, right. None. So this is, of course, 5 and 4, making 2 to the 9th. This is 2 plus 5, making 5 to the 7th. This is negative 3. Why do I have to be careful?
Because it's always negative 3.
Because the 3 has to be in the base. 2 plus 3. So that is negative 3 to the 5th. Will that answer be positive or negative, just for fun?
Positive.
Negative, because it is a negative base and it is an odd exponent. So it's going to go negative, 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 negative. No. A negative base will come out negative if the exponent is odd.
It is really tricky.
What is tricky about D?
Because the 10 is only 1.
The 10 has a 1.
Yeah.
So this is 10 to the 5 plus 1. Everyone forgets the 1. So it is 10 to the 6th. All right? Good. Everyone is comfortable with exponent law 1, yes? All right. You guys are intelligent young people. That makes me very happy that everyone is happy and everybody is comfortable. Now, let's look at exponent law 2. We review again. What does 3 to the 5th mean?
3 times 3 times
3,
3.
3, 3, 3, 3. Agreed? Excellent. What does 3 to the 3rd mean? 3 times 3 times 3. Excellent. What's another way to write the next thing I'm about to write? 3 to the 5th divided by 3 to the 3rd. How do we write that now that we're not in grade 3 and using that symbol? Because we never use that symbol anymore. You could use a slash like a computer does, but what do we do in our math class? No. James says we do a slash. Well, we kind of do a slash, but that's not how we write it. How do we write that? 3, 3, 3, 3, 3, 3 to the 5th over 3, 3, 3. Yes?
Okay, yeah.
Now you guys are smart kids. What is 3 divided by 3? 1. So what do I get to do to them? Cross it out. What is 3 divided by 3?
1.
So what do I get to do to it?
Cross.
What is left?
9.
No. 3 times 3. Do math guys like 3 times 3?
No.
What do they write?
3 times
3 squared. Now, what did I start with? 3 to the 5th. What did I divide it by? 3 to the 3rd. What did I end up with? 3 squared. What's the connection?
So you just take away from the
You subtract. So this is what we call a quotient of powers. Okay? Now, how do we write that? It is x to the a divided by x to the b and all the versions of that. So how else could I write it? XA divided by XB, yes? How else could I write it? XA slash XB. That's it. For you guys, that's it. Everybody cool?
You can write it like
And the answer,
it's gonna be
x to the a minus b. Is everybody cool? Did the base change?
No.
No. Were the bases different?
No.
At the beginning, no. So I'll ask again. Are these laws if the bases are different?
No.
No. It only works when the bases are the same. Now James is going to ask again, what about when the bases are different? And I'm going to say again, we'll get to it.
Is it in grade 10?
No. Yes.
Only the different is the letters. What?
Yes. Okay. So, what do I have here?
It's 4.
How do I write this in grade 9? 4 to the 5th over 4 to the 3rd, which is what? 4 to the 5 minus 3, which is what?
4.
Squared. What's this in grade 9? Negative 2 to the 7th over negative 2 to the 5th, which is negative 2 to the 7 minus 5, which is negative 2 squared. What will my answer be? Oh, sorry, it's 7 over 2. It's 2. I don't know why I wrote 5. I just wrote 5 again. 2.
Like, people just start thinking that that's the number, like...
5. Will that answer be positive or negative?
Negative.
Why?
Because the bracket has the negative.
The bracket has the negative in it, and it's an odd exponent. Everybody good? Great. Those are the two easy ones. Fill this in. Go. It's because you shouldn't even be looking at me. You should be looking at your sheet. Check with mine, make sure you're doing it right. Is everybody good? Okay, now listen to me. These two laws are the basis for all the stuff you're going to do with exponents. If you really and truly understand these two laws, you're okay. You're going to do just fine. So, let's see. Evaluate expressions using exponent laws. So, what do we have here? Well, we have multiplication, division, but what do we do with our exponents?
We add them together.
Add them and subtract them. Are they all the same base?
Yes.
So it is 2. 2 times 3, so that's add, says James. So it's 2 plus 3. But then divided by 4, so that is subtract 4. According to BEDMAS, we do addition first. What is 2 plus 3? 5. So that's 2 to the 5th minus 4, which is 2 to the 1. Would we ever write that?
No.
What's the answer? 2. 2.
Okay.
Everybody good? Hey, Haley. Everybody good?
I think so.
All right. Now look at this one. I got divided by, I got times, and I got 3 negative 2's. What's the base? Negative 2. Why, Liam? Because of brackets. Good man. So that is negative 2 to the 5 divided by, so what's that? Minus 3 times plus 1, which is negative 2 to the 5 minus 3 is 2 plus 1, which is negative 2 cubed. Will that answer be positive or negative?
Negative.
Negative. What would it be?
9 times.
No. Negative 8. Nice job, Liam. Everybody cool? Okay, now I do not want to melt your brain. So we are stopping there with exponent laws. You're going to fill in these, and then you're going to work on page 76.
We almost did the other test.
Okay? Fill those in. When those are filled in, I have one more thing to show you because, of course, there's a bunch of blank white space at the bottom of your notes, right? which means that's where I gotta show you something. So get these filled in. Is everybody good?
Yep. Mr. Myers, I have a question.
Okay.
Why they have too many forms? Like 3 forms.
4, 4, 4.
Yeah, but 1 4 is the first 4 is.
The first 4 we are multiplying, so we do 1 plus 3.
Okay.
Okay, now, couple of things. 1, James's question. Let's have a look at that. 2 squared times 3 squared. I'm multiplying, so there should be a law, yes? What does this really mean? 2 times 2 times 3 times 3. Wait a minute, there is no shortcut, is there? It's just 2 squared and 3 squared. So what's 2 times 2? 4. What's 3 times 3? 9. So the answer is 36. See how there's no law when the bases are different? Because it doesn't give us 3, 3, 3, 3, 3, 3, 3 like it did. Cool? That's the first problem for kids. Everyone okay with that one? Okay. That's problem 1. You want there to be a law, but when you draw it out, you see that there can't be, can there? Great. Problem 2 is this. Negative 3 squared times 3 cubed. What's the base?
3.
They're both 3, aren't they? Because that negative is just at the front, isn't it? Right? So that is negative 3 to the 5th, right? Which is negative 729.
That's a lot.
Everybody cool with problem 2? When the brackets are there, it's easy, right? When the brackets are there, it makes perfect sense, doesn't it? But this looks weird, but we're okay with it, aren't we?
Yes.
Everyone is good? Yes? Okay. Problem 3 is this. 8 times 2 squared. Why is that a problem?
Because
You could do it as 4 times 8, but what if I say use exponent laws? Are they the same base?
Yes, they are.
Kind of. Why, James?
Because if you divide it down, it's 2x over 4.
Isn't 8 2 cubed
Yes.
times 2 squared, which makes it 2 to the 3 plus 2, which is 2 to the 5th, which is 32. Now look up here. What's 8 times 2 squared? What's 2 squared? 4. What's 8 times 4?
32.
32.
you did like a monster.
Does everybody understand why problem 3 is a problem?
Yeah.
Because it doesn't look like there's an exponent law, does it? But there is one. Is everybody cool?
You can do like a divided by 2 equals 4.
Yes, and 4 divided by 2 equals 4. So 8, 2, 2, 2. It's a power of 2.
Yeah.
Let me give you another one there. Can 27 be broken down?
Yeah.
To what?
2 7.
3 times 9, 3 times 3. So 3 cubed is 27. So could I do 27 times 81 as exponents? Yeah, because 27 we know is 3 times 3 times 3. And 81, 9 times 9, 3 times 3, 3 times 3, 3 to the 4th. So 27 times 81 is really 3 cubed times 3 to the 4th, which is really 3 to the 7th. Is everyone cool?
Oh,
And totally mind blown.
Everybody good?
27 get broke up with 7.
No, of course it can't. 7 does not go into 27 at all. All right, now, listen please. There has been a couple of occasions where I have told you that the work we are doing is too important to shirk. Okay? This is one of those times. For lesson 3 and lesson 4, you gotta do it all. You have to understand exponent laws. Okay? You've got 18 minutes left in class today.
Can I go?
I have cut it down quite a bit, every other letter. So A, C, E.
Can I do the quiz?
Yes. Of course. Odds. Odds means similar to every other letter. Okay? Make sure you do it all. All right? Everybody good? 18 minutes is more than enough time to get this done, because let's be honest, what are we doing? Adding and subtracting. Does it take long? No. You're as bad as Omar.
No, but I bring it
You brought it today. Great. Good job.
because I remember, yeah, like I have a textbook, you have to bring it in the class.
Okay. I am going to take attendance, and then I'm going to start walking around and helping people if they need it. It's on your notes, James. You don't have your notes.